Ryan, and I lead the production ecosystem team for Apple Immersive Video. And I am so excited that you guys are all here. So our team partners with the AIV platform architecture team. These folks develop the feature-rich technology that enables Vision Pro to deliver magical experiences. Referencing these two teams helps us distinguish content production-focused elements from developer-focused playback elements of AIV. And today, we're going to talk about what makes Apple Immersive Video different from everything else. We'll start with fidelity of presence. The AIV ecosystem strives to capture, render, and deliver the world in perfect fidelity. And as a reference point, 2020 vision is considered to be that number, what the human can see. Remember, we'll come back to it a little bit later. Next, peripheral FOV, or field of view. AIV delivers a field of view between 180 and 230 degrees. And there's a few reasons for this. The first, viewer comfort. Just like when you sit back, relax, and watch a 2D or 3D movie in Vision Pro, turning around to see something behind you doesn't feel very natural. So, to complete the experience, AIV uses amazing spatial audio technology. We'll go a little bit deeper into that with spatial audio in the next session. The second, suspension of disbelief. Beyond 180 degrees, AIV blends into the viewer's periphery. This helps maintain that profound sense of being there without reminding the viewer they're not actually there. And third is efficiency. By keeping pixels in the viewer's normal field of view, AIV maintains a higher sense of presence. Said slightly differently, each pixel is maximized for efficient streaming without compromising fidelity. The next pillar, dynamic bespoke projection. This is a fancy way of saying AIV has no default or standard projection. It's an interesting concept. This eliminates the need for converting clips to lat long before you start editing, saving production time, render time, and above all, storage space. You don't have extra files. So instead, AIV uses very short experiences that carry the unique lens metadata from the live action camera or CG camera that was used to create each clip. And last, and probably the most important pillar, is world scale. This is that innate human ability to sense distance to an object, reinforcing that feeling of being there. Since Vision Pro reprojects each pixel as it was captured, AIV is free from warping and stitching artifacts, meaning straight lines are straight and objects have natural roundness and accurate stereoscopic cues. To do this, Vision Pro needs highly accurate lens calibration data per shot. That data comes from the ILPD file, or the Immersive Lens Processing Data file. The ILPD file is a JSON, and it's only about 50 kilobytes and sometimes less. And despite that small size, the ILPD carries everything to accurately reproject every pixel in an AIV frame. So let's see how that works. Each lens of an AIV-enabled camera is individually profiled at the camera manufacturer's facility. You can think of this as the optical fingerprint of that specific serial number camera. This profile is then loaded into the camera and is added to every single clip it records. For virtual cameras in DCC tools, there's even a specific ILPD that parametrically defines an AIV projection specific to CG rendering. So using this ILPD, with Apple Immersive enabled post-production tools, we can eliminate the need for manual lens solving, terabytes of intermediate file generation, and easy compositing. The feet of your CG character hit the ground of your live background. And this makes visual effects workflows that much easier. So these are the fundamental pillars that make AIV different, but there's some other differences worth calling out. And first, we'll talk about capture size difference between AIV and 2D. Let's start with frame rate. At minimum, AIV is captured and played back at 90 frames a second. At minimum, AIV is 7200 by 7200 per eye versus our normal 4K size of 4096 by, say, 2160. And last, AIV is always stereoscopic. When you add this all up, you get a 44 times increase in the number of pixels required to achieve the benchmarks that we just talked about being there. That sounds like a really big number a few years ago. But thanks to ProRes efficiency, media extensions for codec developers, and Apple Silicon performance, your AIV editing experience should feel like 2D. Now, obviously, folks don't stream in their production and archive format. So in a moment, we'll talk about how to encode and package AIV for delivery. Having covered what makes Apple Immersive Video different, let's go a little bit deeper into how AIV delivers fidelity of presence. And a hint, it is all about acuity. Traditionally, we talk about videos in the K value. The problem is the K value tells us only how many pixels are inside an image container. It tells us nothing about what the viewer is going to see at the end of the day in Vision Pro. So it's not a very useful benchmark for AIV quality. So how do we define the resolution of an AIV file or format or experience? For that, we use the term acuity. And this term by itself doesn't really help. It's not that useful until we have a scale and a reference point. And for that, we use the eye chart. So whether it's the classic eye chart or the contemporary eye chart that most people in this room have seen at the doctor's office or the optometrist, the principles have not changed since 1862. And the important feature of any eye chart, is that the letters are subdivided, the optotypes are subdivided into a grid pattern. And used correctly, the eye chart can tell us that someone with 20/20 vision, acuity, can perceive about 60 pixels per degree. It's an interesting number. From this, you can start to quantify that feeling of being there by using 20/20 as the benchmark and PPD as the scale. Fidelity of presence relies on perception of distance. How far into the world can we see? That perception of distance creates that innate sense of connection to the world around us. If you've ever seen a video of someone receiving corrective lenses or LASIK for the first time, and most of us have, you know what that connection is. You know the power of that connection. And that perception of distance is a core function of acuity. And acuity is measured in PPD, or pixels per degree. So how does all of this relate to content? We'll do simple. If you take a 180-degree lens and you put it on a standard 8K camera, you get a 24 PPD image, or about 2065 vision. Now, take that same camera and put your friend 25 feet in front of it. At 24 PPD, you might be able to tell the difference between your friend's smile and your friend's grin. But at 60 feet, that distance becomes a little different. You can't tell the difference between your friend and someone dressed like your friend. It gets a little blurry, and that definitely falls short of being there. This is why AIV strives for 60 pixels per degree, and why AIV-enabled cameras have a minimum of 40 PPD, ensuring that content is captured as close to 20/20 vision as possible, both for today and future. If you've ever had the pleasure of working in traditional 3D or VR, you know it's complex. The workflows are complex, the cameras are complex, systems are complex. And so we believe that creating Apple Immersive Video shouldn't be tedious, complicated, or take years to learn. This is why AIV is simple, and that simplicity becomes its superpower. So the AIV ecosystem was designed to be simple. I mean, really simple. Like all-in-one cameras that operate like a 2D camera that generate a single file. Workflows that feel like editing 2D, and an encode and delivery pipeline that feels normal. When something feels simple on the surface, it's usually fairly complex under the hood. And that's why we call Apple Immersive Video a compound format. AIV abstracts the complexity, starting with managing all the various types of metadata in an AIV production, like the lens calibration we just talked about a second ago, or per frame motion data, and we'll definitely come back to that one a little bit later, or dynamic transitions, video transitions rendered by Vision Pro in real time. And there's a few of these, and we do this for coder efficiency and also some really cool features of the format. Going a little deeper, let's look at the basic structure of the two AIV file types, production and delivery. Developers will recognize this as the QuickTime file format. Creatives, you'll recognize this as the MOV file. And just remember, they are one and the same. So it's worth noting that developers like Blackmagic chose to store AIV data in their own format, like BRAW. And also for visual effects workflows, AIV takes advantage of multi-part EXR. And so regardless of the file type that we use to store everything, a few fundamental things are always the same. All video, independent individual video tracks, audio tracks, along with all the per frame metadata, even USDZ assets, background assets, are stored and transported in a single file. This means everything is always in sync and always travels together. No sidecar files, no groups of files to keep track of. This makes AIV feel like working in 2D. So, quick example, a very simple example. You're an editor, and you may be working on the timing of a shot, and you're looking at a single lens view. But before you lock your edit, you want to very quickly verify that there's no smudge on either lens. So you quickly click a button, do your checks, and go back. Under the hood, the NLE is decoding two individual frames, two individual tracks. It's not a side-by-side file. This is just a simple example of how AIV keeps everything at your fingertips without unnecessary files cluttering your timeline. Traditionally, you'd have to link together a single file, a side-by-side file, and maybe something else like a proxy to make this work effectively. Now that we've talked about AIV production format using ProRes, uncompressed, or RAW, let's talk about AIV delivery, and specifically the AIVU file. Developers, once again, keep in mind this is QuickTime under the hood. I'll come back to media prep and packaging in a moment, but it's important to keep in mind that the AIVU file is intended for sharing and playback on Vision Pro. It's not intended for editing or archive. That being said, because it's QuickTime under the hood, as a developer, you could add editing support to your apps for this. So let's walk through how the AIVU file is built. First, the individual ProRes tracks are transcoded into a lightweight MVHVC video track. That MV means multi-view, or left and right views. And as the name suggests, it is a variant of the well-understood and highly efficient HEVC codec family. Next, uncompressed spatial audio tracks and associated metadata are encoded into lightweight APAC audio tracks. We hear more about spatial audio, the spatial audio format, ASAF, and the Apple Positional Audio Codec, APAC, in the next session. Both of these assets will come from your NLE if it's enabled with audio mixing, or a DAW to do your final mix. Next is presentation track. This track stores all of the metadata that signals per clip dynamic changes, calibration changes, fade transition effects, the real-time effects in Vision Pro. You can think of this as a real-time EDL or real-time FCP XML. Developers, you'll know this as MEBEX timed metadata in QuickTime. And like audio, presentation track data comes from your Apple Immersive enabled NLE or DCC. And finally, the AIMI file. This is where all of the camera calibrations, edge blends, backgrounds, and all the other AIV experience metadata is stored. This too will come from your Immersive enabled NLE or DCC. Now that we've talked about production and delivery formats, let's talk about best practices and the technology used to prep AIV media for delivery. Here again, the name of the game is acuity preservation. So first of the best practices to preserve acuity. This simply means not doing things that will negatively impact acuity, like converting AIV into other projection types like lat-long, or downscaling a camera source media file before the encoder final delivery. You let that happen in the encoder. Or shooting with excessively high ISOs in your cameras. Second best practice is image prep. This includes processes like image noise reduction that help with encoder efficiency, or even AI-assisted edge detail enhancement that can help preserve acuity when streaming at really low data rates. Now we'll get into the technologies that are specifically built to help preserve acuity for AIV delivery. And the first is foveation. This is a special imaging process and technique for preserving the most essential data while recording AIV image sizes or reducing AIV image sizes for encoding. Obviously, like we said before, it's impractical to deliver a nearly 11K by 11K image to Vision Pro. So we need to make this fit into AIV's target delivery size of 4320 by 4320 per eye. Again, the name of the game is efficiency. But as you can see, a simple downscale decimates the image to 24 ppd, like we talked about earlier, and that's less than ideal. So to preserve acuity, we want to preserve the most important parts of the image, and for that, we'll employ Apple Immersive Video Foveation. In this step, we'll take advantage of the positive effects of oversampling. And as Tim Dashwood mentioned yesterday, the goal of AIV foveation is not to achieve a specific PPD target, but instead, like the chart shows, it's to help you balance acuity and pixel preservation to meet your creative needs. And because AIV foveation is not one size fits all, you can use AIV's per clip calibration feature to apply user or developer-tuned foveation patterns to each clip. That's a superpower. And that brings us to the most critical AIV technology, the MVHVC tuned encoders, or specifically tuned encoders. Using an AIV-tuned MVHVC encoder, combined with foveation, you could take that 4320 by 4320 ProRes file and encode it to be roughly the same data rate of your typical 2D, 4K, 24-frame HEVC file, without sacrificing that feeling of being there. As I said earlier, I was going to come back to one of my favorite parts of AIV. So let's talk about motion data for the content creator. As Elliot mentioned yesterday, planning for motion in AIV is a responsibility and a tool. AIV motion metadata can be built into every single shot. So you can take advantage of it throughout the decision-making process and the moment in your scenes that really, really matter. In an Apple Immersive enabled NLE, you and your crew can visualize AIV camera motion before you review it in Vision Pro. This is a quick example of what it looks like in Resolve's timeline. There's also a positive and creative benefit to visualing motion data in the timeline. Previously, creators have had to rely on emotional and psychological beats to complete their narrative and story arcs. With AIV and the visualization of motion data, AIV also lets you use this as a story tool. By visualizing physical camera motion in your timeline, creators can craft better emotional beats and arcs to your story before even visualizing it in Vision Pro. And not to be left out, CG animation or CG content, animated content for AIV, has the exact same principles. Motion applies in both mediums. Needless to say, this is a lot of information, but to sum it up, delivering that feeling of being there requires a number of things. Really high standards, simplicity, best practices, and purposeful technology. But that is only 20% of the story. Audio is the other 80% of the immersive experience story. So to talk about Apple's new spatial audio technologies, I'll hand it over to Deep Sen.